The second part of chapter 2 is about organizing data and organizing data specifically by numbers. And what I mean by that is that we're going to use a few numbers to tell us a lot about some sort of a data set or some big group as a whole. Now, we have to understand that whenever we do this, we're going to lose some of the detail, all right? So we're going to lose some of the individual measurements, the individual data points, but we gain an enormous amount of efficiency. So it's very powerful to do this. It's very powerful to be discussing and talk about, for instance, the average of a group or the median value of a group. But whenever we do this, we do have to realize that we are talking about the group and not every individual in that group. So we gain some efficiency, but we have to also realize with that we're talking about the group as a whole and not every individual within the group. So we start out by looking at what we are measuring. And we have two basic definitions here. The first is the definition of statistic. Now, this is not statistics as a study, it's a statistic, all right? So a statistic is a measure of a sample. So it's any measurement we take on a sample. So if we have a sample, we take the average, then I report that average as a statistic. If we had a population, then that same average would be called a parameter. So statistic is a measure of a sample, parameter is a measure of a population. And an easy way to remember that is SSPP. So S sample, S statistics, parameter, and population both begin with the letter P. And it's important to know this, especially when we go back to looking at inferential statistics, because sometimes we really need to keep clear whether the average that I'm taking is on a sample or the population, or if I'm projecting an average from a sample to a population. So being able to do inferential statistics and keep straight everything we're thinking about is important. Also, it's important because there are a few cases where we use different formulas and different notations depending on whether we measured a sample or a population. So we're going to start out with the basic measures of statistics that probably most of you know or have heard of. And the first category of these measurements are central tendency measurements. So measurements of central tendency. Now it's pretty obvious when we say central tendency, what that's really referring to is the center of the group. And because the center of a group is not a well-defined idea, we have different measurements, different ways to find the center of the group. So we're going to look in this class at 4 different measurements of central tendency. The first is the mean. Now again, I mentioned this in an earlier slide on specifically the skepticisms part. I think ambiguous averages. In this course and in statistics in general, the word mean is synonymous with average. So all we're going to do is we're going to add up all of the numbers in our data set and then divide by n. So what I mean by n is going to be the measurement, how many values are in our data set. Now this formula might look a little bit awkward. You might have not seen this notation, but all this is a fancy way of saying we're going to add up all of our values and divide by n. this symbol here, this is a capital sigma. It simply means we're going to add up a bunch of things. So in this case, we're going to add up all the xi. Xi just stands for the values in our set. And then when we divide by n, that's just the number of things in our set. So if I want to look at an example, let's pull up a Word document. Let's say I have the set 10, 12, 13, 18, and 20. We'll increase that a little bit. Well, we all know what we're going to do. We're going to add up 10 plus 12 plus 13 plus 18 plus 20. And since there are 5 values in that set, we're going to divide by 5. And that's going to give us our average. So 10 plus 12 plus 13 plus 18 plus 20. That's really what we're talking about by the sum of this xi. And then when we're dividing by 5, 5 is our n. By the way, let me type that into my calculator really quick and see what happens. In that case, our average is 14.6. All right, so, oops. So our average in that case is 14.6, as long as I calculated it right. So that, again, that formula, even though it has some fancy mathematical notation, it's really straightforward. It's the thing we already know and have seen before. Add up a bunch of values, divide by how many things are in the set. Now, the reason I wanted to introduce this formula is because we will see that sigma notation often in a little bit in the formulas that we use a little bit later. Okay, so we will see that sigma notation again. Now, the second measurement of central tendency is the median. Now, the median defined is the middle value, and by middle value, I simply mean numerically. So we have to list things from least to greatest and pick out the middle one. So, for example, in our data set earlier, we did list these things out from least to greatest. And since 13 is the middle value in that data set, our median would be 13. Now, just for sake of demonstration, even if we switch the order of the values, the median value is still 13. Okay, so be careful about that. Oftentimes we'll get data sets that aren't listed from least to greatest, that have some sort of, that just are randomly, we get random values put in there. And so don't just think that because we see a list, it's the middle number in the list. We have to look at things from least to greatest and then pick the middle number. Now, as a side note, if we have a situation, let's say we missed we add another value. So let's say we added a 24 at the end to this data set. All right, so let me go here. So median we said is 13. Mean we said is 14.6. So in this data set, notice that we have 6 pieces of data. So if I was trying to find a median, I don't actually have a true middle number. So what I have to do there is basically I have to take the 13 and the 18 and I have to say, well, those two are situated in the middle. And so what I do is I just take the average of 13 and 18. So add them up, divide by 2, and we get 15.5. So 15.5 would be the median for that set, okay? Because that's what we get when we go halfway between 13 and 18. I'm going to scroll up real quick. So again, if I have an odd number of values in my data set, then I will always have a true middle. If I have an even number of values in my data set, I'm always going to have to do this. I'm always going to have to go halfway between the middle two numbers. All right, the third measurement of central tendency that you've probably already seen before is the mode. Now, this is simply the number that occurs most often. And there are times when we don't have a mode. There are times when we repeat a number a few times. So it's the number that occurs most often. By the way, oftentimes what we'll see multiple numbers get repeated maybe the same number of times, and then we have to treat that in a certain way. So let me show you a quick example of that. Using the same document I've been using. So if I look at this data set that I was just dealing with, 10, 12, 13, 18, 20, 24. We calculated the median just a moment ago, but what about the mode? Well, the mode for this, everything occurs once. So what we say in that situation, if everything occurs once, we say we have no mode, all right? If we get a situation, and let's make another set. Well, the nicest situation is things like this, where we have 10 occur 3 times, and 18 maybe occurs twice, and then we get 124. And if that is the case, then our mode is simply the number that occurs most often, which in that case is 10. Okay. It becomes a little bit more difficult when we deal with a set like the following. Let's take 10, 10, 13, 18, 18, and 24. Now, in this case, we do have to treat it a little bit differently than we treated the situation with the mean, because the mean was saying, well, what is the halfway point between these two middle numbers? Here we obviously have two numbers, 10 and 18, which occurred more than everything else, but they sort of tied at the top. So if we have a tie at the top, what we don't want to do, we don't want to say 14 is our mode, because that will make people think that 14 occurred more than anything else, which is not true. So what we have to do in this case is we have to say 10 and 18 are both modes. This is a situation which is called bimodal. All right. Bimodal means that there's more than one number that occurred the most often. So bimodal, 10, 18, those, so we list them both. All right. So that's about as quickly and most efficiently as I can explain that. So mode's the thing that occurs most often. The last measurement of central tendency that we're going to use is something called mid-range. And this is simply halfway between the highest and the lowest point. So all we do is we look at the very lowest value and the very highest value. And we go halfway between there. Kind of like in the median, we went halfway between the middle two numbers when we have an even number of values in our set. With the mid-range, we just take the very highest number and the very lowest number, and we go halfway between that. So let's go back to our examples that we were just looking at. Some of these are good, some of these are not. So here we go. If we wanted to do the mid-range, so by the way, that's called mid-range because it's in the middle of the range, of our very first set we used, 10, 12, 18, 13, and 20. I would go there and I'd say, okay, 10 is the smallest number, 20 is the highest number. And so what I would do is I'm going to write out the formula here, 10 and 20, and go halfway in between. By the way, halfway in between is simply adding them up and dividing by 2. So in this case, if you go halfway between, you get 15 as the mid-range. Okay, so the median of that set is 13, the mean is 14.6, and the mid-range is 15. Similarly, all of these, if I go this next set, I wanted to look at the mid-range, what would I have to do? I'd have to go halfway between 10 and 24. So I take 10 plus 24 and divide the result by 2. So the mid-range in this case is 17. Okay. Now, I want to mention one thing really quick, and that something is what I was talking about with ambiguous averages earlier. By the way, just for reference, the mean of this set is about 16.17 if I round it to 2 decimal places. So if you remember with the idea of ambiguous averages, what we said is that oftentimes people will report either like the smallest number or the highest number based on whether they want the set to look like it has a high or a low value. And we can see here that there are distinctions between the median and the mean and the mid-range and the mode. So in this set, if I wanted to make this set look like it has a low value average, I'd probably use the median. If I wanted to make it look like it has a really high value as the average, maybe I'd use the mid-range. Okay. The one nice thing about using the mean that we're going to see, or that we're going to continue to see, is if you think about it, mean is the only measurement of central tendency that gets affected by changing any one of these 5 numbers. Notice that for the median, if I change that 10 to a 9, it's not affected, right? 9, 10, that doesn't change anything. If I change the 12 to a 14, then the mid-range would not be affected at all. The mid-range only looks at the highest and lowest values. But no matter which value you change, your mean will, okay? So the really nice thing about mean, why people talk about it so much, is that it takes into account every single value of your data set. And the median, again, you can change some of the really high values and some of the really low values, and it's not going to affect the median. And if you change the middle values, it doesn't affect the mid-range. And if you change some of the values, let me scroll down. If you change some of the other values of this set, if I change that 18 to a 19, obviously that does not affect the mode. So the mean is nice because the mean does take into account every single value from our data set. Now, I want to give you some notation really quick here. Because mean takes into account every single value from the data set, it's going to be the most important measurement of central tendency that we'll use in this class. And so we're going to have a shorthand notation for mean. And that shorthand notation is going to depend upon whether we're talking about a mean of a population or a mean of a sample. So what we do oftentimes is we'll use Greek letters when we're talking about population measurements. So when we're talking about parameters, and when we're talking about sample measurements, in other words, when we're talking about statistics, we'll use a lot more English, standard English letters. And so that's what you see here. The population mean is a Greek letter which is pronounced mu. It's sort of like an mu, so pronounce it as mu. And it's like the Greek letter that makes the M sound. So it kind of looks like a U with a little bit of a line out front. And what I would suggest right now is you'd try to write that symbol, because we're going to use that symbol a lot. So we need to get used to it. Write down mu 4 times, and then next to it how to pronounce it. MU. It sounds like a M and a U put together. So anytime you see the letter mu in this class, it's always going to refer to the population mean. And similar, anytime you see an X with a bar over it, it's going to be referring to a sample mean. All right. So when we're dealing with this statistic, we'll call that X bar. So just X and then bar. So an X with a bar over it is a sample mean, and a mu is always going to refer to as a population mean. Now they're calculated in the same way. We're just going to add up all the values and divide by n. But we want to have a different notation so that when we get into inferential statistics, we can say, oh yeah, that's the mean of the sample, and I'm trying to project that onto this, the mean of the population. Okay. One other little side note, oftentimes when we're talking about sample size, we use lowercase n, and when we use population size, we'll use uppercase n. And that's, for most people, that's pretty straightforward. Population is the bigger group, sample is the smaller group. So uppercase n for population size and lowercase n for sample size. Now, here's what we're going to do. We're going to look at and try to find the mean, median, mid-range, and mode for the following set of data. All right. So these data show a bunch of ancient manuscripts. And with that, they show, So with these ancient manuscripts, they have the number of ancient manuscripts which we still have intact. Okay, so for instance, Thucydides, believe a Greek author, there's 8 ancient manuscripts that we have intact that are Thucydides' history. Now, I don't mean he wrote them. These are obviously copies of the original, but it's 8 ancient manuscripts. And by the way, how we define ancient is a little bit arbitrary, but it's within a certain time frame of the initial time they were written down. All right, I had to adjust my slide so that we matched up with the guided notes. So the point is, we're trying to find the mean, median, mid-range, and mode. And we have these 9 data points, and we're going to figure that out. Now, we could do all this stuff by hand. If we wanted to find the mean, we could have added up all 9 numbers, divided by 9, and we'd have found the mean. If we want to find the median, we could have listed things from least to greatest, and then found the median. The mid-range, similarly, we could have found the smallest and the highest number, averaged those out. Mode, we could have found the most often. But what we're going to do, at least for these first 3 measures of central tendency, is we're going to start utilizing our calculator in order to figure out things, okay? Now, our calculator, this TI-84 that we had to get, is actually really good at finding the mean, median, and pretty darn good at finding the mid-range. All right, we have to kind of rig it to find the mid-range. The one thing it takes a while to do is to get the mode. So what I'm going to do is I'm just going to say, let's get the mode by just looking at the data set. So if we look at this data set and we're trying to find the mode, well, 7 occurs twice, 8 occurs twice, 5, 10, 20, 9, and 0 all occur once. So we would say that the mode is, well, in this case it's bimodal. It's 7 and 8. So we'd write down both 7 and 8 for the mode. Now I'm going to switch to a different view here. So the mode, what we just did is we found that the mode is 7 and 8. Now for the other measurements, we're going to try to utilize our calculator. Okay, hopefully this will work. What I'm going to do is I'm going to pull up my camera. I know it's going to be looking a little bit backwards, but I'll show you kind of how to input things into our calculator and get this. Hopefully it's not too far of a stretch to see it backwards. I don't know how to flip the screen though, so I will do this way. So here's my obviously webcam, and so I take out my calculator, my TI-84, and I'm going to clear things out that I don't want to have in there. Okay, so if you look at this again, yours is going to look a little bit backwards from mine. I don't know how to flip the camera. I'll try to ask around our tech people. So what I'm going to do is I'm going to go to this stat button right here. Okay, stats, and you'll see a few things. You'll see an edit, a sort, clear lists, setup editor. So what we're going to do in order to input data is we're going to go to stat, edit. So all we have to do is go down to either hit the number 1, or when we get to stat, edit, hit enter. Oops. Now, oftentimes there'll be things in our list already. Okay, you'll see here list 1, list 2, and so on and so forth. Okay. Well, that blue box is a little annoying. So what we're going to do is we're going to input things into list 1. Now, just as a note, if you already have stuff in there, what you can do is you can go up to the L1 and hit the clear button. The clear button is down here. And then if you enter, that'll clear out the list 1. Okay, so list 1 is cleared now. Now I can start putting in my data. And all you have to do is just type the numbers that we have in our data set. So back to here, if you would, into list 1, type in the 8, another 8, 5, 10, 20, 9, 7, 7, and 0. All right. Once you've typed those in, once you've typed in all 9 of these numbers into list 1, then it's a pretty straightforward button approach to finding the measurements that we're looking for. So what I'm going to do, let's see if we can focus. Maybe this is a little bit on the bright side. There we go. So focus. Into list 1, there we go. Now all we have to do is go back to stats and then over to calculate. Now we're going to use one variable statistics, so hit enter. And there's actually 2 different versions of the inputs that you could see. One looks like this, where it says list and then a frequency list. If you have this operating system on, then the list should be the list we just put the data into, which was L1. Now, in order to get L1, all we have to do is hit the second and then down in the number 1. So hit second and then down in the number 1. You will see right above the number 1, we have L1. So second, number 1, there you go. Now, right now, we don't have a frequency distribution. It's just raw 9 numbers. So what we'll do is we'll just delete anything out of our frequency list and then use that to calculate. So if you have this operating system, list is L1, don't put anything in your frequency list right now because we don't have a frequency distribution, and just go down and calculate, hit enter. Now, if you look at the display, the first thing that pops up is an X with a line over it. And we know that as the shorthand for a sample mean. Now, just for the record, if this was a population of manuscripts, remember I said the means are calculated the same way in either case. So if this was a population, that would still be the mean, and we would just have to realize that we should have really, when we write it down, we should write down the symbol mu instead of x bar. So for right now, all we need to do, the point of this is just to say 8.22 is the average, and there we go. Now if we scroll down that list, so very first number is the x bar. If we start pushing the down arrow, and by down arrow I mean the arrow right here on your calculator, so we start pushing the down arrow, what you'll see is at the very bottom there's MED. I shouldn't say it's not the very bottom number, but it's towards the bottom. We have MED, and that MED should say 8 if I've calculated this right. Also take note there's a minimum and a maximum. So notice we don't have a mid-range, but we know that mid-range is halfway between the minimum and the maximum. So if I were doing this, I would take a look at my display and I'd say, well, the median it gives out is 8, and the mid-range, well, it doesn't give me a mid-range, but it's halfway between 0 and 20. So if I add up 0 plus 20 and then divide by 2, I end up with a 10. Okay. And so for the manuscript data example that we have here, our average is 8.22, our median is 8, our mode, well, it's bimodal 7 and 8, and our mid-range is 10. Okay, so that's how you utilize your calculator in order to figure out your measurements of central tendency. Okay, now what I'd like you to do, since we already have these 9 data points in our calculator, why don't you go ahead and just add a 10th. And the one we're going to add, the final one we're going to add, is the New Testament. And so these first 9 are all exactly what we just typed in. And then we add another one, which is the New Testament. So I'd like you to take your calculator, go to the Stats Edit menu, just scroll down past the 9 numbers you've already put in, and in the very 10th entry, put 5,600. Once you've done this, practice hitting your stats, one variable stats. In your calculate menu, list should be L1, frequency list should be blank. Now, just as a note, because I know some of you do not have the same display on your calculators, some of you probably have just one variable stats with a blinking cursor. I wanted to show you how to do that as well. And basically, it comes down to whether your calculator has a program called Stats Wizard. Okay, so real quick, I'm going to change the mode on my calculator so it reflects that. All right, so now If I don't have frequency list display, instead if my calculator just has one variable stats, so again, it's the same sequence of inputs. We go stat, calculate, one variable stat, and obviously I have a blinking cursor instead of a list display. And so what I would do if I have this, oh, that's better, this display on my calculator, all I have to do is hit second and then the L1 button. So if I hit second and the L1 button, hit enter, and I should get the exact same display as somebody who has the Stats Wizards options. So there you go. Again, it looks backwards right now. If I could flip my camera, I would. I'm sure there's a way to do that. I'll find out using contacting my IT people a little bit later. So the point is, it's the same exact display. Oh, you know what? It's the same exact display, but obviously the numbers have changed quite significantly. All right. So if I go scroll down, so the example with the New Testament, now the mean has changed to 567.4. And scrolling down to the median stayed at 8. The mid-range, well, now my minimum still 0, my maximum got really, really big. So 5,600, halfway between that and 0, so add 5,600 plus 0, then divide by 2, gives me 2,800. And like always, the calculator doesn't efficiently give me mode. There are some ways you can hack it to do that, but as far as mode goes, for this class, we're just going to look at the actual data that's given. In this case, the only thing that got added is one really, really large number, and we can see that the mode doesn't change. The mode is still 7 and 8. It's still by mode. Now, hopefully, we can compare and contrast the manuscripts with 9 different classical books versus this manuscript example with 10 classical books. And the things that you should jump out at you are the fact that by adding this really, really big number compared to the rest of them, that really big number compared to the rest of them really made the mean increase, and it really made the mid-range increase. So it increased the mean by quite a bit and increased the mid-range by a ton. But notice that the median and the mode did not change from example to example. The median stayed the same, even though actually what's happening here is 8 is a single middle number over here because we have 9, and both these 8s are middle numbers in this example. So the median didn't change, the mode really didn't change, but the mean did get pulled higher, and the mid-range got pulled a lot higher. So what does this tell us? This tells us that the average and the mid-range are fairly affected by are largely affected by very big numbers compared to the rest of the set. An introduction of a really big number into a set can really pull the average up, and it can really pull the mid-range up. Mid-range is most affected, but the average is also affected. Now, it's actually this reason is why when reporting income data, people almost always use median income when they report income data. Because obviously if you grab one person who's Bill Gates or Jeff Bezos or Warren Buffett, people who have multiple tens of billions of dollars. If one of those people falls into your sample, it's going to look like everybody's extremely rich when you calculate the average. And it's going to look like everybody's extremely rich if you use the mid-range. But the median is not affected by a whole lot. Again, if I collected everybody's income data in this class and then asked for the average income, well, if Warren Buffett were to walk in and join the class, the average income would go through the roof. The median wouldn't change by much. So it's for this reason that income data and lots of other data, when they report central tendencies, they use the median. Okay, again, mean is really nice because it uses every single value, but sometimes, again, if you're trying to look for the general trend, median is better than mean. All right, sometimes. Again, mean's better for a lot of things too. Mean's better because in the sense that it uses every individual data point. Median's nice because it kind of lets us ignore really, really big numbers or really, really small numbers. Now, if we have this set of data, all right, this set of data is references 20 people whose weight I calculated, all right? Now, this is imaginary data. This is not actually, I didn't actually have 20 people step on a scale and measure their weight, but the point is, let's pretend that I had 20 people step on a scale and I measured all 20 of their weights. What I'd like you to do is pause this I'm going to have you pause this video, but what I'd like you to do is on your own, calculate the mean, median, mid-range, and mode for this data set. Now this is one data set, so as far as the lists go, this, even though it's like arranged in a 4x5 grid, still put all 20 pieces of data into list 1. So right now, pause the video, try to calculate the measurements of central tendency, and in about 5 seconds, I will start back up. All right, hopefully you did that. So again, put all of the data, stats, edit, put all of the data into list 1. Then, once you've done that, go to stats, calculate one variable statistics, and then L1 should be your list. So again, depending on whether or not which version of the operating system you have, it should be list is L1 or just one variable stats and then L1 right next to it. Now, if you've done that right, you should get an average, you should get a mean of 161.45. Okay, notice, by the way, I'm rounding everything to 2 decimal places. Anytime we're talking about averages or medians, or we'll see other types of measurements, we're going to round it we're going to round to 2 decimal places. Okay, the median, once I scrolled down and saw that, that's 166.5. Normally, since it stops at 0.5, I don't need to round that any further. But you know, if it did have decimals going on and on and on, we'd round it to 2. Okay. Now, as far as the mid-range goes, the minimum was 305 and the smallest value was 38. So if I calculate halfway between that by adding up 305 plus 38 and then dividing that number by 2, I get 171.5. All right, so my mid-range is 171.5. Once again, mode is the thing that I haven't put down yet, that my calculator doesn't do a real efficient job of getting. And so By the way, our calculator doesn't. There are programs that do a very good job of getting modes, but it's more cumbersome than it's worth for dealing with it in our calculator. So we just go through the numbers. 157, that only occurs once. 189, that only occurs once. And I keep going on and on and on until I see that 174 occurs twice, and there's no other number that occurs twice. So the mode is 174. So my measurements of central tendency are on display there. Okay. Now, if we go to the next example actually is an example that uses a frequency distribution. Now, whenever we're dealing with a frequency distribution, we have to realize what this means. So what I've done is I've went out and I've looked and I've surveyed a bunch of adults, a bunch of married adults. And what we find is that 3 of those adults had 0 kids, and 5 of those adults, so 3 of the adults had 0 kids, 5 of the adults had 1 kid, 8 of the adults had 2 kids. I think I said adults, maybe it's just couples. 9 of the adults had 3, and so on and so forth. There was 1 person who had 5 kids and 1 person who had 6 kids. And so that's the breakdown. Now, if we were to do this longhand, what we would have had to have done is we'd had to take 0 plus 0 plus 0, and then plus 1 plus 1 plus 1 plus 1 plus 1, and then add 8 different 2's up, and then add 8 different 3's. But our calculator is going to do a much more efficient job of this. So all we have to do is we have to put this into our calculator right and ask it the correct question. And the nice thing is it's pretty straightforward. It's much like what we just did. What I would do is I would take the number of kids, this column, and I would put those numbers 0 through 6 into list 1. So I go into list 1, again clear it out if we need to, and hit 0, enter, 1, enter, and all the way until you get to 6. And then in list 2, what we're going to do is we're going to type in those frequencies. So we're going to type in 3, 5, 8, 9, 4, 1, and 1. And what we're going to have the calculator do is calculate the average based on this frequency distribution. Or as I say average, median, mid-range, based on the frequency distribution. Okay, so this frequency distribution we can see right there. The one thing I do want to mention that I'm sure you did naturally anyways is you do have to make sure that there were 5 people with 1 child. Therefore, you need to make sure that the 1 and the 5 match up and that you realize that your frequency list is L2. All right, so that when we go to stats, calculate, we're going to do one variable statistics again. Now, just for a moment, let me talk about there is a 2 variable statistics mode. This is not 2 variables. Frequency is not a variable. The only variable here, the only characteristic that can assume different values is the number of kids. The frequency is not a variable. It's just a count of how many there were. So this is still 1 variable statistics, but we have a frequency distribution. So when you go into 1 variable statistics, if you have the operating system that pops up and it says list and frequency list, it's pretty obvious that the list we're going to put in as L1. And then the frequency list, now we do have a frequency list. So we type it in as L2. If you don't have that operating system, if you have the operating system that gives you this display, then what you have to do is you have to put in L1 first, and then a comma, and then L2. So, by the way, the comma is right above the 7, so you just hit second, and then the number 1, and then a comma, and then a second, and then the number 2. So that's how you would display that on your calculator. Whichever method you have, once you hit enter, you should get this exact same display. And from that display, we can read off the mean, the median, the mid-range. Well, we don't really read off the mid-range, but we can find the mid-range based on that display. So here, our mean, obviously the numerical answer goes on for a lot of decimals. Again, don't forget we're going to do standard rounding just to 2 decimal places. So 2.42 is the average. Once we look at the median is 2. The mid-range. Well, if you notice, the minimum and the maximum values are 0 and 6. Don't get thrown off by frequency. Frequency, when we say mid-range is the minimum number of kids and the maximum number of kids. That's what I have to use. Frequency is just, again, a count. So mid-range is halfway between 0 and 6, which if we add them up and divide by 2, you get 3. Mode. Now the last thing, again, we don't have on our calculator is mode. So which person, or which couple, I guess. It's phrased as couple. I phrased it as person earlier. So which person, or not, I shouldn't say which person. What is the most often number of kids that the couples had? And if you look at this, the most often number that occurred was the number 3. Okay, 3 occurred 9 times. In other words, when I say mode, essentially what we're saying is what number had the highest frequency. So since 3 occurred 9 times and everything else occurred less, the mode is 3. Okay, again, don't get thrown off by that second column. All right, so here's the deal. On our previous example, the list of numbers that we had were 0, 1, 2, 3, 4, 5, and 6. Those were all whole numbers. What would happen if my frequency distribution, instead of having single numbers in the list, had ranges of numbers? So, for instance, what if I looked at this income example? We have different classes. That first class goes from $0 to $49,999. And it has a frequency of 549. So in other words, 549 adults, their income fell between those ranges. And so on and so forth for each category. Now, the trouble with this is that the calculator, well, it's twofold. One is that the calculator only allows us to put in a single number in every entry in list 1. So we can't tell the calculator that, the first entry in list 1 is from 0 to 49,000. What we have to do is we have to come up with a single number for each of these classes. And what we do, or the number that we use, is going to be the middle number. All right. Now, the reason we use the middle number is so that we can get the least amount of error possible. So for instance, if I were in this last set, there's one person that has an income between 350,000 and about 400,000. So there's one person in that range. If I pretend that that person landed right on 350,000, but in reality, that person landed on right about 400,000, I would be a total of 50,000 units off. And so what I do is I split the difference. I use 375,000 for that last class, and then the most I can be off is 25,000 in either direction. So for the income data, 0 to 49,999, we're just going to use 25,000 as that value. Let me write that down in the guided notes and talk about what I mean by that. So we have this. We're going to use 25,000, all right, for that class. And for the next class, what we're going to use is well, the middle number is 75,000. Whoops. And so on and so forth. Okay, 125,000. Oops, I do that a lot. For the next one. And so what I'd like you to do is fill this thing out. Use all these middle numbers and put 25,000, 75,000, 125,000 all in list 1, all the middle numbers in list 1. And then in list 2, you input the frequencies. So I'm going to push pause while you do that. I want you to do that and then use it to calculate the mean, median, mode, and mid-range. All right, hopefully you did that. Now I'm going to erase this from my notes. You can put it in your notes if you'd like, but I'm going to erase it from mine. So when I do that, list 1 becomes 25,000, 75,000, 125,000, 175,000, 225,000, 275,000, 325,000, and 375,000. And then obviously for the frequency list, we'll put that into L2 and we'll put in all those numbers, 549, 291, and make sure they match up. So in other words, the 549 should match up to the 25,000 that we plugged in. I don't really have to even do that. I probably shouldn't. And once you've done that, make sure you should have already went to stats, calculate one variable statistics. If you have the one operating system, you go list L1, frequency list L2. If you have the other operating system, you do list one variable stats, L1, then a comma, then L2. Okay? And you should end up with the exact same display either way. The mean is 61,150. By the way, just as a note, since these measurements were all in dollars, technically the mean is also going to be in dollars. So 61,150. The median, I got the median at 25,000. We'll come back and talk about that in a moment. Okay. The mid-range. Well, my minimum was 25,000. My maximum was 375,000. So it turns out if you look at the mid-range of between 25,000 and 375,000, that comes out to $200,000. Guess I could put commas in appropriately. Now, as far as the mode goes, there's two ways to do this. One way is to say, well, the mode is 25,000 because it has the highest frequency. But oftentimes what we do, and I'm going to write this term right below mode here, is we write down what's called the modal class. So when we have ranges of numbers, oftentimes instead of saying the word mode, which kind of is referring to a single number, we use the word modal class, and to signify that it is the class that occurred most often. So the class that occurred most often was 0 to 49,999. So that was the class that occurred most often. So we call it the modal class. Okay, so mode, modal class, those are kind of interchangeable. Now, one thing you should notice about this example is that because of this issue, that this one person whose income is from 350 somewhere to almost 400, but we don't know where, because we have to represent that one person with a single number, if you use the raw data here, you might get a different mean, median, mid-range, and mode. Okay, that's just the name of how frequency distributions with ranges work. Also, when we look at the median is 25,000, but really that 25,000 was a proxy for this entire class. So it might be that when we looked at the raw data, we know that the median is going to show up in that class, but maybe the median was closer to 48,000, or maybe the median was closer to 45,000, all right, instead of the 25,000 that I'm using. So in one sense, as far as median goes, if I don't have the raw data, if I just have frequencies and classes, then what we have to realize is that 25,000 median really means that the median income landed somewhere in this class. All right, so hopefully that makes a little bit of sense. What I'm going to do now is I'm going to stop this video, and we're going to continue on with how distributions are shaped and what the spread of distributions looks like and how to use those things in a couple of other videos. So normally this portion of the lecture would be sort of broken up into multiple lectures. So that's what we're trying to mimic here.